in Sleaford East signalbox, which is a recreation of the original Sleaford East as best as you can by my good colleague Alastair Larter. And if I get this right, you've tried to get as much as you can original as per the original box.
Yes.
Yes. So we've got a 24 lever frame, Romford, which you've restored fully. It's a BPRS frame. You've had it relocked. You've fitted, as we can see in the next little bit of the video, all the electric locks unlocking under the floor. Lovely gate wheel in the corner, we'll have a look at in a minute. Fantastic relay set up there in the corner in the wooden glass cabinet, and there's more downstairs as well. This building used to be a piggery. So Alice has built the frame in situ and then demolished the old roof and then rebuilt the box on top. The windows are Blow-toft signal box, so there's as much original bits of signal box in here as you can. Do you want to just explain what I'm actually looking at on the diagram? Where are we here?
Okay, so this is Sleaford Station here. You've got the line coming in from the Great Northern Great Eastern Joint Line Lincoln on this branch here. Line from Grantham this side. Out this side we've got the line to Boston and Skegness, which is the main line. We've got the loop down to the GNGE, which is the up and down joint, and then the line at the bottom here is a single branch to Billingborough and Bourne.
And you control Sleaford East, but obviously you've got some demonstration signalling controlled from Sleaford West, which is in your outbuilding, which runs some of your block instruments and your indications.
Yeah. So all the blocks are fully connected to another set of blocks in the other building. So we're full absolute block on the running lines from Grantham to Boston, Spalding, and also the local line, which although it's a single line, it still use double track absolute block instruments with quite a unique circuit on it. The single branch to Bourne, which was originally worked with block and ticket, it's actually worked by tablet machines, number 6s.
Tablet machines here, which Alice has got working, and these work. Am I okay to press?
Yeah.
So, as you can see, it is wired up and it does work, fully working. Your colleague Pete Burke made the bits, the labels, beautiful labels. Yeah. Tyres patent, Train Tablet Apparatus London. And David's made you the tablets that go inside the machine. So it's a joint effort between several people. Block instruments wise, there's a mixture here of the BR Standard, the Penguins, the black and white, and some of the lovely old wooden block instruments. Do you want to tell us a little bit about them? Okay,
so the original Great Northern style block instrument. This is the Pegger. This is a short cased non-Pegger that's had the bottom cut off, which originally all started in this style.
As modular, right?
Yeah, and then they shortened the case on them. That's the small style Great Northern block. If we go to the other end of the shelf, there's the large style. The same job. It's made by the same people, but there's the large case and the small cased ones. That's a Great Northern set. This is a Great Northern non-Pegger, but this is actually a Great Central block. And the difference, although they initially look very similar, is the trigger mechanism handle.
Yes.
That's got the thumb peg, and that's got the...
This has got the rear handle peg.
Yeah.
Yes. That is a totally different mechanism. It's amazing how many different mechanisms there are for all the signalling around the world. Little pin there. There's the peg in. So, simulation-wise, can you show us anything working on the frame at the moment? Because obviously you've got a lot of functions simulated, like your points you described.
Yeah, the points, the electric motor points, and if we bring across you
can hear it
in
whirring.
the background. So normal, cross to reverse.
So what else has got downstairs, for those who don't know, he hasn't actually got a set of motor points outside in the garden. He's actually got a small miniature set of model railway points downstairs that do the same job that you can hear moving across. So you can still get a simulation of the motor points. What else is there to see?
Number 4 signal, it's got a banner repeater. So if we pull number 4.
And the banner repeater is just outside. I'll show you that in a minute.
And
See
there
the
we
indicator
go.
going
It's
across.
repeated. Off it goes across.
Alistair's redone a lot of these indicators because they were missing. So there's a video on the RAC site. That's the one of these indicators you can see that is rebuilt.
Number 1 and 2 levers actually aren't signal. 1 and 2 are the 2 distance signals.
Coming from Sleaford West.
Yep. So they're the 2 distant signals, one from Lincoln, one from Grantham. But there's actually some weight on them.
That's the weight that's downstairs.
What I've done with them is the counterweights underneath with a standard tyres circuit controller on to operate the circuits on there. So you've got some weight on all the levers. Eventually there'll be a ground frame release on 13. But you'll notice there's a lot of white stripes.
Yes.
A lot of line clear, and that's because working from right to left, so if you're working from Sleaford East to Sleaford West, coming in this direction, you've only got a distance and a home.
Yes.
That's it. It's very short working. So you need a line clear release from west before you can clean these. Because that acts as a home and a starter to get the section release, and that's why there's so many white bands.
And Alistair's drawn this. This diagram's been done up in paint, by the way, for those of us who remember paint as it used to be, and it's several sections of diagram. It's a lovely looking diagram.
Originally set off as Welland North, and it's been cut and paste to suit the situation. So took a picture of Welland North diagram, dropped it into paint, and then it was all cut and paste to near the original as we could get it.
And all the track circuits are simulated on the diagram as well.
All the track circuits are simulated on the diagram.
The simulator box over there. So
we've just got a simulator box at the minute, which will eventually be the computer. So if we go, there we
there's
are.
a train coming from the west box. Getting down there on the down main. As it clears through the section. All interlocked with the blocks as well, so it throws the blocks across as needed. And a few other things we've got in this box here, just to add the scene for. I'll show you outside in a minute, but if you just look around at what there is in the box, from the original telephone circuit cards, signs, all the telephones that Alastair's got wired up between here and the other parts of the simulator, even down to the baby belling stove, the original lockers, lamps galore, and the fittings in the box. It's absolutely beautiful. I mean, the amount of work that's gone into this is just fantastic. How many hours would you reckon you've put in so far?
We're about 8 years so far.
So I won't even calculate the hours there. That's a lot. That's a lot. But there is a lot of work in here, and it's just unprecedented, the amount of work you've put into this.
Locks.
So there's 18 locks under the floor, Westinghouse L-style locks.
Yeah.
And you've had all your tappets machined yourself to fit.
No, I've just got I've chosen the locks to suit the
frame.
Yeah, it was already machined. I've got the only thing is, I was told which locks I wanted.
Yeah.
And I told you that I was told I needed normal reverse for
Yeah.
the point, and I need MB
DRs for
DRs. So
motor points.
Dave's going to machine the slides for me.
That's a hell of a lot of work under the floor there. And lever 1 and 2, the distance, they've got, you can't see them, but they've got some tail weights just down there to simulate the weight. It's under here, isn't it?
They've got
there they are.
40-pound weights on.
So they've got tail weights on. You can just see there to simulate the weight of the actual distance. That's a lovely setup, and you can get at it all, and it's just sat under the floor.
Yeah, and then these floor bars, they sit in notches in here.
Ah, yeah.
So you can lift the bars out.
If you need to get in there.
If you need this lock out, you can lift it out.
That's good. So we're here now under the floor of the signal box, and what we have is our power supplies here. So we have our 240, 110, 50 volt supplies in there. We have our fuse board out, using the standard cartridge fuses and the China fuse holders. And remember the point motors we heard earlier, moving over and back? There's 3 of them in here to simulate point motors outside in the real world. Our backup supplies over there, and moving around. Apart from the relay interlocking upstairs, we also have our 930 plug-in relays down here. So there's even more interlocking downstairs, and that's it. That also works in conjunction with what's upstairs. And then we have our frame out over here into the open world space.
That, and then 3 relays there. Track circuit repeaters, point repeaters, signal control relays up at the top. This side you've got your earth leakage, your backlock timers, and there's some Sleaford West control signals, which control relays for signals that's not installed yet, going to go on there. Okay, so on the left hand side of the cabinet, all these link connectors this side are the links that go over to the block shelf. Across the top here we've got some 12 volt, some 6 volt and some 50 volt fuses. There's 3 polar relays, which are the GKRs for signals 1, 2 and 3. If we come down the shelf, we've got the polar relays, which are the on the block circuits. We've got the BZR relays, and these 2 relays here are going to be the stick relays for the block circuits. We've got a track relay and track repeating stick relay there. Come down and we've got another set of polar relays with BZRs for the down main and the local, and we've got G track repeating relay and J track repeating relay down there. Across the bottom we move to more traditional 930 series relays, which are a lot of the repeating relays, track repeating relays, branch down distant, and there is also a lamp proving relay in there for the distant signal.
And for those who aren't familiar with the old shelf type relays, just a little interesting note here. This red mark on the top infers a line relay, which can be used at a higher voltage, so say 12 volts, as opposed to some of the track relays which work at a much lower voltage. And also, those of us who've worked on these over the years, we call these nodders or Daleks, and basically these are your terminal covers, which you split up for when your wires go on. So if, for instance, if we're going to cover this terminal here, it would beautifully cover these. They do yellow after a few years, so they do need replacing, and they're usually the first thing you get lost in a cupboard. I can attest to that. And again, for those who've never worked on shelf type relays before, there is a pin code on these, just the same as there is on the 930 series. The pin code is these pins on the front. There are 2 types of relays. There are the shelf type relays without the top, detachable top on, and then there are the detachable top types, which are called Remax tops. And if you undo this OBA screw on the front, this head itself will actually pull itself off, and then you can lift it off. Once it's completely off, it clears these studs here on the sides, 2 on the left, 2 on the right, and then you can lift these off. These were designed to aid in having to take the wires off all the time. So you just undo this one screw, take it off, you change the relay underneath. The pin code, if I remember rightly, is actually labelled on these. On these, it's on the front of the labels on these as well, on the old 930s. So again, everything's detachable, even down to the polar relays. Some of these have a Remax top on as well. Plastic screw there, and you can undo the frontage on these. There are various ones, some do, some don't have them. Yours
They've all
have
got them on.
Yours have all got them. Fantastic bit of work that, Alastair.
Okay, so the gate wheel came from Wainfleet in Lincolnshire. No restoration on it whatsoever. It was simply taken out of the box, brought here, put into the box. So you've got the main casting, the wheel, and the locking lever on this side, the miniature locking lever. That goes down through the floor onto a drive shaft, which then has an actual tappet in the main locking tray.
And looking at it, that's a heck of a piece of weight, Alastair. Did you manage to move it all in one?
Not all in one. The wheel comes off, the head comes off, the drive shaft comes off, the main crank comes off, and then the main casting splits into two. So it is in components, but still very heavy even when it's split down.
I believe at some point in its past, it's actually had some repairs, because one side has a steel pin and the other side has a brass pin.
Yep, so the steel pin in this side was a replacement when somebody swung the gates a bit too hard and snapped the end of one of the pins.
So for those of us who don't do too much with gate wheels, this is the locking lever to the frame.
That's the proving lever that you've wound the... so if we look on the wheel, there's a hole.
There's a hole just there.
Yep, and that's got to line up with the pin there.
Pin comes through.
And then you've got two white marks on here that your gates are
Lined up with.
open and closed, and that's where you wind your alignment to.
Now, Alistair's very kindly let us have a look inside the tablet machines here, and just a very quick overview of tablet machines. Tablet machines issue a disc, which is the driver's authority to enter the single line, and it's also interlocked with the starting signals entering the single line section. You have a handle here which pulls out the magazine to drop the tablet out so that you can get the tablet out. You have a counter on the front which tells you how many are in the machine, and traditionally they are brass or steel. The weight helps to keep the tablets down so gravity can feed them out. You have had versions in the past which are plastic, but what you tend to find is you have a metal one that you put at the top to keep the weight in, or they're very heavy. Inside, as you can appreciate, a lot of interlocking there, the coils of the release on the machine itself, and this is also drives the indicators up in the top of the machine here. You can just see there, and Alistair's going to give us a little bit of a talk about this, because you know more about tablet machines than I do.
Okay, so you've got your main slide mechanism through here. You've got your catch handle this side, which when you pull the catch handle you can see the release to allow you to withdraw the slide. No tablet in there because the other machine's not corresponding and saying let a tablet go. You've got signal proving contacts this side, so if you want to have a signal that's released by tablet only, you use these contacts here. Some are normal closed, some are normal open. You've got two sets of lock coils, a left hand and a right hand set. Commutator up at the top, so this is very similar to turning your commutator on a block instrument. The other machine holds their commutator in, the needle flicks, and that allows you to turn it anti-clockwise, and that'll move your little mechanical indicator to say that the tablet is out. Withdraw the tray and you can then take your tablet out. The little needle at the top here is your galvanometer. Flicks left to right depending on which polarity is being fed to the machine. And also up in the top here there is another set of coils which operate the top indicator, which tells you what the other machine's doing. The two machines are linked over a pair of wires or a wire and earth, and it simply flicks the polarity depending on which correspondence the machine is in. Unlike a key token machine, the block bell is remote to the machine, and you can see these mounted in various positions, sometimes vertical on the wall or on the shelf like we've got it here. The unit comes with two wooden doors on this side, which we'll show you when we build the machine back up. Domed top, wooden top with a glass front in the...
And much like a token machine, you got full access to be able to get in there. Some token machines do have a lid that completely comes off as one. Some have sides that come off in various pieces. This one you can get good access to. There is a lot of bits and pieces in there to make this machine work, but as Alastair's pointed out, the signalman has a galvanometer, so we can see the state of the bell signals between both boxes, indicators, operating plunger, and a tablet release tray. And you can see how many tokens are in his machine, same as a token machine. So tablets, tokens, very similar system. This weighs quite a lot, doesn't it?
They're very heavy.
Very heavy.
Not a one-man lift.
Comes on its own mounting base. Traditionally, these are where your power supplies were before, and as Alastair mentioned, the doors come off the side as well. So in here, this is where Alastair has his proving relays, which work the system. Is that a tablet down there you can just show us, Alastair?
That's a fibre tablet. So this isn't from this machine. This is a configuration with a round circle. They all have the notch in the bottom, but you can get square, triangle, to give different configurations, particularly if you've got a midsection box and you've got single line either way. You wouldn't have a circular one with a circle in the middle and a circular one that side. You would have different configurations, so you can't get the tablets
so much
over.
The same then as a token system. You have different tablets for different systems, so if you've got more than one tablet machine in a box, it's configured for that system. Again, much like a token key, which also operates the ground frames in the middle, tablets have the ability to be placed into locks on remote ground frames where they actually form part of the interlocking that releases the ground frame itself, hence what the notches are for and the discs in the middle. So this would sit on a pin shaft and it would form part of that interlocking to release that ground frame. As I mentioned, this is a fibre one. There's not much weight in it, so you can appreciate you need a bit of weight to keep the tablets dropping down, otherwise they can stick. So traditionally brass or metal. That's lovely.
Yeah.
Oh, and yes, inscribed of course with the section.
With the sections on. So if we have a look at this, we're showing in, which means both machines haven't got a tablet out. We're locked there. We talked about the signal proving contacts. So if we go to the diagram, we'll see that number 12 is released by tablet. So if we try and pull number 12, it's got the white band on it. It's currently locked because that machine hasn't got the tablet taken out.
So we're just going to take a look inside one of the wooden case blocking instruments. As we mentioned, they're called peggers for a reason, because you can peg them up. So as you can see, you press the gun handle at the back and you can set the indicator left or right. It's trapped on this little beveling here, and another beveling on the other side there. So we release the pistol grip and it drops back to its middle position. Inside the terminal, brass terminals, we have the Spagnoletti mechanism itself, which gives us the indication line clear or train on line. Default to the vertical position or line blocked. The terminal blocks inside, as you notice this little sawtooth arrangement, I was told many years ago, there's a small piece of doped material between them, so that in an event, say certainly on a token machine, if you had a lightning strike, it will flash over. So the centre one should go to earth, but this isn't wired up. I've seen token machines wired as such. And then you have your terminals inside, which are set through the actual wooden casing, and our mechanism, rocking mechanism inside. If I can just peg that across, you'll see it operating. So you can see it breaks contact on that side. Peg the other way, breaks contact on that side. Obviously it's not flicking across the line clear because we have not operated the sequence of relays correctly. But as you can see, that's how the mechanism works. Fairly simple. To think these used to be made up in workshops up and down the country, lovingly looked after by the older technicians. And then we have our BR standard block, traditionally called the Penguins. I actually like these, grew up with these. Again, for those who aren't aware, the black section is what you control. This is your pegger indicator, your pegger, just the same as this. That's your pegger, this is your pegger. Your bell, again on the wooden case instruments, the bell is separate. And then the white section at the top is your non-pegger from the other signal box. So if Sleaford West was giving us an indication, this is where we would see it. And if we were giving Sleaford West an indication, we would see it on our bottom half here. Much the similar layout, line clear to the right in this case. You can have line clear left and right on these, that's a regional variation. So depending on which set you've got up, you either have line clear left or line clear right. And again, some of the diagrams that Alastair uses, copied from another railway, you will see A, B and C relays. Again, for those who may not have come across this in the past, A, B, C. So C, position, B, position, A, position, because in this case, line clear is to the right. So, as with any block circuit, you must prove the last train has cleared the section complete and all signals are back on before you can get another line clear. So, starting position, always peg train on line to make sure you've cancelled the last train out the section. C relay picks before you can give a line clear, A relay. And the sequence has to repeat again and again. Train passes through, train will or should automatically knock this across the train on line. It depends on the variations of the circuitry. Not all of them do that. We call this compulsory train on line block. So if normally, traditionally, a signaller would, as soon as he gets 2 bells, he would peg across the train on line. However, if he forgets or he goes to the toilet or the train comes and drops the track, as is going to happen now, and then it will throw it across the train on line. And then what we'll have to do is we'll have to cancel that out by pegging train on line to make sure before we can drop it again. And we'll go through the sequence all again. The main arm's clear in there, and now when Westbox clears his signals, the distant will clear off as well. That's a motorised one. And both return to danger. That's a crossing indicator just gone to red, and also we have a working telephone as well. Hello, signaller. So Alastair's going to show us inside now one of the filament failure units on the block shelf. Would you like to tell us about it?
Okay, so in one of our previous videos we had a look at the standard Bakelite Midland region lamp proving unit. This is typical Eastern region one, does exactly the same job, apart from they're individual, they don't stack up. So inside the unit you've got the relay, a bell unit, the needle indicator rather than a light that's on the Midland region one, and the changeover switch. So if the lamp failed, the bell would ring, the needle would swing to out, and the bell would sound. Replace the lamp, the needle would swing to in, return the switch, the relay's picked and the bell stopped.
And the same as on the Midland region, if the switch is out of correspondence with the lamp outside, it will ring. If the lamp fails, that will ring until you cancel it, and then when the S&T technician comes and puts the lamp back in, it will again ring to say the lamp's gone back in. Signalman has to cancel it off on the switch. Quite a compact little setup there. There are several different types of these you'll find on various heritage railways. There's this one which has the nice brass case to it, but there's also a more cast version, such as this one here, you'll tend to find a lot of. Bell on the rear, and a couple of, well, 4 terminals on the back there. Posi neggy, lamp in, lamp out as such, and that's more compact unit. You see those a lot used as power on off switches, ironically, on a lot of signal boxes.
So this is the welling type, the square type. There's two different types in general. One is the round type, which we've covered previously, that mounts on the front of the shelf. And then there's the square type that go on the top of the shelf. More common to Eastern region, this, although they have spread their wings a little bit into the Midlands as well. Both work on the same principle. You've got a disc this side with the normal on. You've got two sets of contacts, a pair of normal closed and a pair of normal open. And if you peg incorrectly and you need to wind out, you turn the wheel on the side, the disc rotates all the way around, it opens your contacts, closes your contacts, and you bring it back to when the N shows in your little window, and then your blocks can operate as per normal.
So that's welling block, and the welling winder is there to ensure that should you need to cancel that line clear without a train having gone through the section, that the interlocking is sure that you're cancelling it for the safest and correctest reason. So it forces the signalman to stop and do something for 60 seconds, however long it takes him to wind. The other thing about these winders, you cannot wind them backwards. That's one of the tests we have, because they stick. They are a cogged system. So am I okay winding?
Yeah.
Right, so if I were to wind this, it's not the easiest wind in the world, but as you can see, your block is thrown across now. And you wind and you wind. And it's forcing the signalman to stop and think. You can't do anything else while he's winding. There are versions of this that are relay based, so they're just timers, but you still have to sit there with your finger on it until that comes all the way back up. It takes around about a minute. And when you're winding it, it seems to take forever. And I don't know if you can just see it, the end's just coming back up. When the end's fully within the window, the contacts will remake again. There you go, the needle's just dropped on this one. And we're back where we started.
Weight on this one.
So the next stage in Alastair's project here is to fit a 2-lever ground frame? 4-lever ground frame, and that's going right here, and that's what's going to be worked to those ground signals you just saw cleared around there. That's Alastair's next part of his ground frame. He's been making this ground frame up now for a while, out of various bits you've had to unbend.
It was a 1-lever ground frame.
And it's slowly made all the fittings up, and that's where this is going to sit, and that'll be the next part. As you've already heard, Alice mentioned there's a release lever in the box for that, so that'll be wired in as well to work them ground signals down there. So this is Alastair's ground frame location that is installed ready. Notice signal power supply, which is running some lighting in some of the signals. So he's got it all wired up and ready to go in with the ground frame next door to it when that goes in. So you can wire that into the simulator as well. Here, if we drop the track circuit, see, automatically goes across the trailer line, and we need to agree with that block and clear our train through our section. We're just doing it quickly here before we can cancel off and drop our block and start again.